Welcome to this explainer. Today we're diving into the fundamental building blocks of our universe to solve a seriously fascinating microscopic mystery. I mean, have you ever wondered what's actually happening right in front of your eyes when one thing seemingly turns into something completely different? We're going to explore the invisible world of particles to figure out exactly how matter rearranges itself to create the incredible variety of substances we see every single day.
So we're kicking things off with this incredible phenomenon. Picture this. What exactly is happening down at the particle level when you take plain, ordinary water, hook it up to a battery for a jolt of energy, and suddenly, you produce two completely new, invisible gases? It kind of seems like magic, right? You start with a liquid, you add electricity, and suddenly, bubbling up are substances that simply weren't there a moment ago. How does one substance become two new ones?
Now, to make sense of this, let's compare our battery mystery to something we see all the time, a simple phase change. Think about boiling a pot of water for pasta. When that water boils, the particles just absorb heat, speed up, and spread apart to become water vapor. But there's still water particles, right? The core identity of the substance hasn't changed. But with our battery setup, what scientists call a chemical reaction, we aren't just spreading things out. We're actually creating entirely new substances. But water is disappearing and different gases are taking its place.
Section 1. Atoms and molecules. Look, if we're going to figure out how new substances are built, we first need to know what tools nature has in her toolbox.
And it really all comes down to two foundational concepts. First up, atoms. You can think of atoms as the absolute smallest indivisible building blocks of matter. They're literally the universe's Lego bricks. Then you've got molecules. Molecules are compound particles. They're specific combinations that happen when you snap two or more of those atoms together. So when we talk about a particle of water, we're actually talking about a water molecule, which is built from even smaller atoms.
What's honestly mind-blowing about this is the elegant simplicity of it all. Just a handful of atom types combine in these totally unique arrangements to make up every single different substance in our world. I mean, if you have a glass of pure water, every single molecule in that glass is exactly the same. It's the specific number, the type, and the geometric arrangement of those atoms within the molecule that gives a substance its unique properties. Change the arrangement, and you change the substance entirely.
Let me show you exactly what I mean here. Check out these chemical formulas. 2 hydrogen atoms and 1 oxygen atom combined give us H2O, right? Good old life-giving water. But if you take that exact same arrangement and just tack on 1 extra oxygen atom, you get H2O2. That is hydrogen peroxide, a totally unique substance and definitely not something you want to drink. It's an incredible reminder of how precise these molecular recipes are. A single atom is the difference between a refreshing drink and an antiseptic for a scraped knee.
All right, moving on to Section 2, modeling the breakdown. Let's see how scientists historically tackled this puzzle of tearing particles apart to solve our water mystery.
So early scientists like the brilliant John Dalton started mapping this out with some pretty simple drawings. At first, Dalton thought a water molecule was as basic as it gets, just 1 hydrogen atom and 1 oxygen atom stuck side by side. Honestly, it was a great starting point for wrapping our heads around how molecules form, but as scientists ran more experiments, they quickly realized this picture wasn't quite complete.
And this right here brilliantly shows the revised, super accurate model we still use today. A water molecule actually has 3 atoms, 2 hydrogens, 1 oxygen. And when you zap it with that energy from the battery, that 3-atom molecule goes through a massive change. It physically breaks apart. The atoms disconnect and then group back together in totally new ways to form completely separate hydrogen and oxygen gases. You're literally dismantling the starting material to build something fresh.
You can even visualize this like tearing apart a solid object. Imagine a solid blue circle is our original water molecule. The electrical energy acts like an invisible pair of hands, just ripping that blue circle into smaller, distinct pieces. And those smaller pieces, those represent the individual hydrogen and oxygen atoms. So the original molecule isn't just spreading out, it's structurally broken down to its base components so they can be reused.
Which brings us to Section 3, the chemical rearrangement. This is absolutely crucial, and it's the definitive answer to our microscopic mystery.
A chemical reaction is not magic, it's just nature's interlocking blocks doing their thing. First step, the molecules of the old, original substances are literally broken apart. Second step, the atoms that made them up get shuffled and rearranged. And finally, step 3, they snap back together in new configurations to form entirely new molecules. The old water molecules are gone, and newly constructed gas molecules are sitting right there in their place.
Section 4. Conservation of mass.
Now, there is a major catch that governs this whole microscopic dance of breaking apart and snapping together.
This quote highlights an absolute foundational law of our physical world. Even when we're tearing those water molecules apart with a battery, the atoms themselves are never destroyed. You literally can't wipe an atom out of existence, and you definitely can't chop it into smaller fragments during a chemical reaction. They just disconnect and find new partners. The inventory of atoms you start with is the exact same inventory you end up with, period.
And that brings us to the conservation of mass. Think about doing a chemical reaction inside a totally closed system, like a perfectly sealed glass box where absolutely no matter can leak out and nothing can sneak in. The total mass inside that box will stay exactly the same before, during, and after the reaction. Because every single atom is accounted for, the weight doesn't budge. It's the ultimate rule. Matter is neither created nor destroyed, it's only rearranged.
The cool part is we can apply this incredible rule to stuff right in our own homes. Take a fizzy bath bomb, for example. You toss it in the tub, mixing water, citric acid, and sodium bicarbonate, which is just baking soda. Almost instantly, the water churns and this totally new gas violently bubbles out. That fizzing, that is a real-time chemical reaction. The molecules of those bath bomb ingredients and the water are breaking apart, and their atoms are frantically rearranging to build those new gas molecules right in front of you.
So, I want to leave you with this question. Knowing that absolutely no atoms are ever destroyed and zero mass is lost in this process, what exact new molecules form to create those bath bomb bubbles? Where did the carbon, the oxygen, the hydrogen atoms actually shift to? Next time you see something bubble, rust, or even burn, ask yourself, what is the hidden microscopic chemistry happening right there, and how are the atoms rearranging to build our world? Keep questioning, keep observing, and thanks so much for joining me on this explainer.